What's up, everybody? GM Corey here from DreadVectorStudios. Today we're going to be going over the ALSCameraManager for your Advanced Locomotion System V4. So if you have been struggling with the inbuilt camera system that comes with this project, we're going to take a deep dive, take a look at what's going on under the hood, and see where we can make changes to optimize for your project. That'll all be on your end, but we'll explore it today and we'll definitely demonstrate how the changes can impact the overall gameplay effect. All right, so first thing I want to go over is the camera itself. So I've got a few simple things in the project here. I'm not going to go over in this, so this is a third tutorial that I'm going over in this project. I've still got my torch stuff in here, and I also have got this night creature in here that was free for the month, I believe, in October. I've gone and removed all that content in from our character, so everything is back to default with a very few exceptions. Nothing that's going to impact us today. So the first thing I'm going to do is, if you're in your content folder here, I always like to expand this here. It always makes things just a smidge easier, and then I can see what folders I've got. So primarily, you're going to be working out of the blueprints folder today. So in here, you'll find the character logic and the camera system. So understand that the two are intrinsically linked, and we're going to have a little bit of difficulty. There's tutorials out there on how to unlink them, but understand that your camera object is a character in the way this is being handled. Almost as complex in that it has its own animation blueprint. So if you look at your camera system here, the first thing you're going to see in here is that you have this hot pink camera, all right? So this pink camera here represents a skeletal mesh. So it has a skeleton to it, not that it has anything in the skeleton. Actually, if you look at it, it's just the boom. Okay, so why did Caleb go and build in a mesh, a skeletal mesh for the camera? And I'll tell you, it's actually very simple. If you look at the camera manager here, he's using a camera, an animation blueprint. So you have your camera behavior skeletal mesh here on the blueprint. And if you scroll all the way up to the top over here on the right, you'll see he's got a skeletal mesh defined, and he has the player camera behavior animation blueprint on here. No, the camera doesn't have any joints, or it's not actually using anything skeletal mesh or anything animation required, other than the fact that it has an animation blueprint. But why does it have an animation blueprint? So the first thing I want to show you here with the animation blueprint, if we go into the event graph, just here at the base, the first thing it's doing is it's using that event update animation to update character information from the character. And it's using the ALS player camera behavior for this. Okay, that's the animation blueprint that we're in. Why is he doing that? Because he's got all of these variables here that are state interactive with the character. So for instance, if I set my right shoulder variable on the character, it'll update it in this function here. So you'll note the update character info function. It's going to perform a sequence of operations, and you'll see that it's all active here based on the animation. It's going to get the controlled pawn, which is the character, right? So from there, it's going to use a blueprint interface. It's going to assume that the character has the ALS character blueprint interface. I'm not going to go into interfaces right now. Understand that it's just a way of sharing a variable and the value associated with it between two unrelated objects. It's nothing really all that wizardry. You subscribe to it up in class settings. This object isn't actually even subscribed to it. You can see no interfaces here. But it's using a message, and it's assuming, I would personally cast it to an ALS base player character or the Animan character blueprint before moving forward, but it's a pretty safe cast here. It's a pretty small system. So it's going to assume that it has those values, and it's going to set all of the values in this blueprint based upon what is going on every time it updates the animation. That event update blueprint animation, or event blueprint update animation, is going to be called regularly, almost, I believe, as frequently as tick. So what is it doing here? It updates the variables here that we are going to then use to drive our camera. We don't have any animations on the camera, you say. Well, that's okay. We don't need animations. What we've got is an animation blueprint with cached poses, and he's using curves. So this is where you're going to understand that it's an animation blueprint. So we have main camera states here, and this is what he's doing. You have velocity direction, looking direction, and aiming. These might look familiar from your character base file because those are the states that he's getting from over here, and he's using them to transition between these different look values. So just for a frame of reference, we're going to jump in, look at the debug interface, and figure out what these actually mean. Okay, so here you are in the scene, and if we look at it, hit play here. Okay, I for character information, and then we're going to note here just about the center of the screen, it's going to say rotation mode, looking direction currently, okay? So I'm just going to eject for a moment, or Control F1 here to get my cursor. That doesn't work. Oh great, I think I broke it. There we go. Unlit, lit, there we go. All right, Control F3 to get back out of that, sorry. Eject, F8. Okay, so you can see that we've got looking direction currently as the rotation mode. And if we look over here, we can cycle the rotation modes by pressing 1 and 2. So I'll hit F8 to jump back in, tap 1, and it's going to alert me behind the character's head. Click back over to 2, and it's going to put me off to the right shoulder. If I tap C, it'll put me to the other shoulder. And it's just going to alert me between these locations relative to the character. You'll notice that if I rotate the camera, it's always going to try and stay over the right shoulder of the capsule. Okay, so again, I will go ahead and tap C, and now I'm going to stay over the left shoulder. Okay, and perfect. You notice it also says looking direction now. And if I tap 1, it's going to say velocity direction. And if I right click, it's going to go into aiming. Here, let me jump to the other shoulder so you can see that. There, now it's jumping into aiming. That's what this is jumping between. The location that the camera is supposed to be at is being tracked on a curve. Now, what does that actually look like on here? We see that the rotation mode is changing, so it swaps into the looking direction or the aiming. And inside of each one of these, they all look very similar, and that's intentional because we're just modifying a few choice values. So we're going to go to the velocity direction just to explore this real quick. And we're going to look at these 3 curves. So let's start over here. All right. So the rotation lag speed is how long it takes for the camera to turn. This prevents motion sickness and things like that. You can adjust it here so that you don't feel too offset. If your camera is rotating too slowly, for instance, not keeping your weapon targeted at your cursor, you may have a problem with your rotation lag speed here. You can fine tune it. It's a super easy variable to change. Now, default blend time is 2, which is, I think, related to gain time 2 seconds, but there's also the crouching blend time and Y. Okay, so we're looking at your stance variable, pulling it in, and it's going to be the default is your standing. If you note, you click here, you can add the standing position because default is just going to assume whatever is not explicitly stated is going to fall into the default pose. So if you just make this blend poses here, check this out. Blend poses by ALS stance. Note it only has the default pose. You can right click and add standing or crouching. So what he's done is added the crouching stance here, and then it gives you these 2 variables here for how long it's going to take to transition between them. Put in the enum value there, boom, you're duplicating that exact functionality. So what's it determining? It's determining on the stance whether you're crouching or standing. And if you're crouching, it's going to use these values. Otherwise, it's going to use these. And it's just going to decide between those. The next decision it's going to make is on your character's gait. And this functions exactly the same way. It's going to choose between walking, running, or sprinting. Okay? And you have your blend times again. You can also add in some additional views here, since, for instance, you've got walking, so if you wanted to specify it exactly. And then ultimately, this is the meat of it. So the modify curve is just going to be handling the X and the Z. In other words, the forward directionality distance for where the camera should be positioned, and the vertical, the Z, of where it should be positioned. Now, it's also going to have some pivot lag here on how long it takes to get between positions based upon your character's stance and gait. This allows you to adjust the camera feel of different poses. For instance, when you start sprinting, should the camera lag behind you a little ways to make you feel like you're going faster? Should it drop a little closer to the ground to emphasize that forward lean that's being layered in through the animation blueprint on the character itself? There's a whole lot of different ways in which this is helpful. I'm going to quickly compile this again. So the default pose, the running pose, and the sprinting pose. Now, same thing applies if you're in the crouching position. So the first thing you're going to notice, negative 325 points behind your units behind your character and 20 points above your character. Okay, well, that doesn't explain why it's off to the shoulder, but we'll explain that in a second. Camera offset Y is 0 here because of that. All right, we're only going to be handling the X and the Z through your stance and your gait. We just want to know how high and how close the camera should be relative to your character in this section. Now, if we go back into the animation graph here and we look at looking direction, it's doing the exact same thing with some minor difference in the values. It's got a camera offset Z of, or a Y of 70 in here, and it's only 280 behind you when you're aiming. It's going to a very specific locked location, okay? But it will be overridden depending on what else you're doing. So let's take a look at it. This is just a baseline. And then these are what I like to call the root position. And then you have the aiming, and you can see it also has a little bit different values in here depending on how you are modifying your stance and your gait. All right, that's it. We cached the pose. That's where your camera should be as a base position. The next thing, that's layer 1. That is the root, where your camera ideal position is. But there's a bunch of modifiers on it. For instance, the shoulder swap. Should you be left shoulder or right shoulder? Just toggled back and forth by tapping the C key by default in the UI. And it's going to multiply your Y offset on that previous value by 1 or -1 so that it can handle left or right shoulder, left or right, and which is your Y axis. And then it's just going to blend between the two based upon this amount of time, and then it's going to cache the pose. That's it. Next step is it's going to take that cached pose, and the reason the poses are being cached here, you might wonder why it's being done over and over again, is that you're using the cached pose as an input into each one of these, and as this functions as an execution line for the animator, you can't actually have multiple things that or one object that leads in multiple paths. Just like all other blueprints, you can't have your execution path split without a decision like a branch. Okay? So, cached pose, for instance, if you are rolling, high mantling, or low mantling, or if you look at the base one here, getting up, or none, both fall under the default pose, then it's going to use or not use this additional lag speed. What is the lag speed? I want to go over this because it's actually really easy to demonstrate here. By default, we're going to use the rolling pose because it's super easy to see. All right, so the only thing we're going to do is we're going to hit double tap Alt to roll. Note how your camera dips down towards the ground and then follows you back up, and then how long it takes to do that. All right, the speed the camera is moving. So if we go back in here, and we're just going to modify this to say 0.1 on all these values, and then compile. Okay, go back in here, hit play, and when we double tap Alt, now it takes forever. Our camera just like sinks down, and then when it goes out of that roll, it has to speed up to catch up to where the camera should be. So it probably not the desired behavior, but you're seeing exactly what you should what can go into this field and how it will change the field. Let's change to 20 to go higher than the 5 that it was originally. And then come back over here, hit play, and now you'll notice that it doesn't slow down at all. It just stays right with the character because it is actually lerping between the locations faster than the desired position is moving. Okay, so let's put those back to 5 and move on to the next layer in this beautiful cake of positioning the camera. All right, first person. Here's where everything's wrong, okay? You've zapped into first person, you can see your nose and your eyes, or there's something wrong with the way your character's turning, or all this, or you can't see your hands. This is the weighting for the first person camera. If it's 0, then it's just going to use the default ALS that we've gone through up to this point. And if it's at 1, it's going to use the first person pose. So the first person pose basically zeroes out everything. It's not even cached anywhere in here. There is an override position for it, but ultimately it's going to be the root. Okay, so I wouldn't worry too much about it. It's going to take the cached position in and it's going to override it. No big deal. Next thing it's going to do, same exact concept, but this time we're going to explicitly state where we want the curve to be. So if you wanted to emulate this into your first person view, you can copy this node and drop it right here. And then when you're in first person, it's just going to go wherever you tell to put the camera in first person mode. Okay, super simple modification there. And then you can see that it's got a camera offset for the ragdoll here that's going to be 320 units behind you and 50 units above you. It's going to completely overwrite your left-right shoulder thing. And then it's going to, here's your blend speeds on it. And then it has a pivot offset as well. The pivot offset is, I believe it's the look direction, yeah. So the pivot offset is going to be that it looks down a little bit more towards your character because you're ragdolling, you're laying on the ground. And then it gives you a lag speed as well in here, which is additional to the other ones. You can add a whole bunch of curve pins on here that aren't, like, you gotta wait, aim down sight, wait first person, all kinds of things that you can bring into this struct. So the modify curve is extremely powerful if you know what curve you are modifying. Okay, and then it caches it yet again, and the next thing it does, boom, it pulls in that ragdoll override and checks, is it true or not? Are you doing the debug view? What is the debug view, you might ask? So if you come in here and you look over on the right hand side of your screen, you'll see if you're in debug mode, it is debug view. You just tap V. Perfect. So, boom. Now you're in the debug camera. You can still control your character. So you just can't control where the camera is. So you can turn. It stays relative in X world position to your character and doesn't follow you around. So you can watch all kinds of interesting things where you look up and down and ignore where you're actually going. Kind of like me on a cell phone when I'm walking. Okay, so next thing, if you want to visualize where the camera is actually sitting and you want to see what's going on, it's very easy to go back into your player camera blueprint object here, click on your ALS PlayerCameraManager, scroll down until you find the actor hidden in game and uncheck that. That's all you got to do. I think camera behavior also hidden in game. This is your static mesh. You can see the white box here. This is the one you really want to see. The blue camera box doesn't actually have a visual collision in the game to show you, but you have to turn off the hidden portion in the root, the scene component, before you can, or the actor, before you can actually view the static mesh, and it's hidden in game on the static mesh. So set that back to default, compile, save. Now when we come in here, hit play, and we're behind the right shoulder here, we can then press F8 to eject and see where our camera is physically located, though we can't control our character right now because we have to eject. Otherwise, this camera object is going to stay attached to the viewport in the game. For instance, in the debug view, you're still technically in the camera manager, so it'll stay attached to you. I hope that makes things a little simpler and you can see where you can dive in to check things out. Give me a like, give me a subscribe here on YouTube, and if you're over in the Advanced Locomotion version 4 server on Discord, please hit me up if you have any questions, and I would love to help you out. So I will see you in the discussion chat, and happy game dev. See you later.